Any question? So I will send you the quiz in Moodle today by 7, and it will be due at midnight.
So you're sending it tonight at 7
Yeah.
and still on it?
Mhm. So I'll send it to you. So you check your Moodle at around 6:30, 7 p.m. So you know how to scan it using your phone. So you can scan it and then make sure you save it as a PDF. So you save as a PDF. So it's like 3 to 4 questions. It's not that much. It could be section, I think section 5 and part of section 4 and 5. All right, so today we're going to look at section 6.3. I send your notes, the notes to, you can check your notes at Google. So I think this one is the simplest section. So what we're going to do is we're going to factor perfect squares. Then also we're going to look at the factors of cubes. So like what we did last time we were here, we're going to see how to factor the squares. So if you're given a perfect square, then how would you factor? All right, so let's start from difference of squares pattern. Difference of squares. And this one is always common. So mostly when you're given a square minus b square, we all know this, right? So this is equals to what? When the factors of this will be what? A minus b, a plus what? A plus a minus b, a plus b. So when you expand this, you always get this one. So let's try expand it. So a minus b, a plus b. So how do you expand this? How do you expand that? So here, this is the same as a. You can take this one and then you multiply by this, a plus b, minus this minus here, b, a plus b. So this is what we did last time, because we were factoring out the common factor there, which is a plus b, and then we take a and b there. So when you open the brackets here, then what you get is a and a will be a square, plus a and b will be a b, minus this minus here, a and this one, b and a will be minus b a, and then this minus again, when you put it inside here, then it will be minus b squared. So finally, what you get is a square AB is the same because these are symmetric. So AB minus BA is the same. So it will be plus 0. And then this will be minus B squared. So finally, you get A squared minus B squared. So that is a difference of squares. So that is a difference of squares. So if you're given an example, x squared minus 9, x squared minus 9. So x squared minus 9 is a difference of squares because the square root of x is x, and then the square root of this one is what? Is 3. So it will be x minus 3 and what? X plus what? X plus 3. X minus 3, x plus 3. So there is a difference of squares there because when you open these brackets, then definitely you get x squared minus 9. Now, again, if you have an example like the one which I put it in your notes, 49y squared minus 49x squared. Is this a difference of squares? Is this a difference of squares? Okay, so what you do here, you factor out the greatest common factor there, which is what? 49. So when you factor out 49, then what you remain with is y squared minus what? X squared. Y squared minus x squared. So the one which is in the brackets is a difference of what? Squares, right? So the one which is inside the brackets is a difference of squares. So definitely that is 49. And then what is inside here will be y minus x, y plus what? Plus x. So finally, is the same as 49, y minus x, y plus x. So here, this is like multiplication. This is like multiply, and then that one is like a multiply. So when you multiply the three factors here, then definitely what you get is the 49y squared minus 49x squared. Okay? So you factor out first the greatest common factor, and then you look whether that one is a difference of squares. Okay, there is another example which I put it in Moodle. Now, if you are given y squared plus 49z squared, is that a difference of squares? Is it? That is not a difference of squares because of the what?
Plus sign.
Of that plus sign there. So that is not a difference of squares. So the solution will remain like this. You cannot factor that. So you cannot factorize this one. Okay? So you cannot factor it. All right, another one here. Example 75 q squared minus 180 q plus 108. Factorize that. So this one will lead us to another section, which is called perfect square. So this will lead us to the perfect square. So well, we have, if we given, you have a square plus 2ab plus b square, and this one is always the same as a plus b square. A plus b square. Then another one, which is a perfect square, is a square minus b square, which is the same as a plus b, a minus b. So I don't know whether you learned something to do with the Pascal's triangle when you were in high school. Did you do something like a Pascal's triangle to get the coefficients of a trinomial or something like that? Did you do something like this? So if it is, if you have, let's say, a plus b, and then you put 0 there, then the coefficient is 1. So if you have a plus b, then you put 1 there, then we have 1 and 1 there. If you have a plus b, and then you put square there, then we have 2, 1, 2, and 1. So these are the coefficients. This and these are the coefficients. I don't know whether you did something with this. Looking for the coefficients, or you use the binomial. Did you do something like this again? If you have that, then you use that combination. Did you do something like this? If you do not do it, then you don't have to worry about it. So these are the coefficients of, if it is a square, these are the coefficients. So these are like this. So this is 1, this is 2, this is 1. So the coefficients are 1, 1, 1, 2, 1. If it is a plus b cubed, then it is 1, 3, 3, 1. So these are the coefficients. So if this is a cube, if this is a plus b, and then cube, then this is equals to a cube plus 3a square b plus 3ab square plus b cube. Okay, so the coefficients are these 1, 3, 3, 1. Don't worry about it. Maybe you'll do it in college algebra. You might do it. So if we come back to that, so I've said the perfect squares are a plus b squared. When you expand this, then this is like a, then a plus b, a plus b. So if you open these brackets here, then it will be a squared. This and this will be plus ab. This one and this one will be, this and this will be plus ba plus b squared. So finally what you get is a squared plus 2ab plus b squared. Then the one for a minus b is minus b, a plus b. We already did it. So this is a squared minus what? B squared. A squared minus b squared. So, like the example which I had put it there, 75q squared minus 180q plus 108. So how will you factorize this? Using the perfect squares. How will you factorize? So first of all, what you do is you look at this if there is a common, greatest common factor in 75, 180, and 108. What is the greatest common factor there? So if you divide by 3, what do you get? So if you divide by 3, then that is 3. So this will give us what? Is it 25? Q square. And this one is what? Minus what? 60. Is it 60? Plus, this one is 30 what? 39, right? 36, sorry. So this one is 36. So to get the factors here, then you come and look at this and then this one to get the values of A and B. To get the values of A and B. So when you get the square root of this, 25q square, what do you get?
5q.
5q, right? So you get 5q. So when you get the square root of 36, what do you get? 6. You get 6. So you have the two of them there. So here, then let's say 5q. So this is 5q. Then square there, okay? So that is 5q square, which is for this. Then we have now what is here. Will it, when you multiply, what is remaining here? Let's say what remains there is, when you multiply, will you get 60? And then the final one here is 6 square there. So what will you multiply there to get 60 there?
Negative 10q.
So we have, when you multiply here, then it will be 6, and then we have the 10 of q there, right? Okay? So to factorize this again, then what will be the factors? How will we form the factors over here? What will be the two factors formed from here? So definitely we start by 5 and 3 there, and then we have the 5q there. And then the last one, which is what? 6, right? Okay? So we have the 6 there. So if you square these, the two of them, now what will be the sign over here so that it can give us a perfect square? So if we put the sign here to be -6, and then we square this, will it give us the 5q minus 60q plus 36? So if we expand this, then what you get is 5q minus 6, and then when you multiply by 5q minus 6, 5q minus 6, then what you get is 25q there. And this will be what? Minus 30q. This one will give us what? Minus 30q there. And then this and this will give us plus what? 36. So when you simplify that, then you get 25q minus 60q plus what? Plus 36. And then definitely we have the 3 outside there. So when you open these brackets here, then what you get is our final answer here, which is this. So our other perfect square is this. A minus B squared. There. So A minus B squared is the same as A squared minus 2AB plus what? Plus B squared. So we have 3 perfect squares. So we have the first one, which is the difference of squares, and then we have this, and then we also have number 2, which is A plus B squared, which is equals to A squared minus plus 2AB plus B squared. So another example is like if you're given 9c squared plus 42c plus 49. How can we factorize this to see whether we can get a perfect square? So here I can see it can be like number 2 here, okay? So it's like number 2 because there is no minus here. So what you do, you write like this, in this form. So a square is like getting the square root of this. And the square root of this is like there is 1 there. The square root of this is what? 3c squared, okay? Then plus this sign, you just carry it like that. And then there is a 2 here, 2 there, okay? There is a 2 here. AB. So AB is, we are getting it from here. So A is like 3 there, okay? And then B is the one which you get from here. And the square root of 49 is what? 7. So A will be now be AB, which is now 3 there, and then 7 there, and then we have the C there, which is this, plus now the 7 squared, plus the 7 squared. So when you multiply 2 times 3 times 7, is it giving us 42? So it is giving us 42. So that means this is a what? Perfect square. So this we now write in the form A plus B squared. So it will now be 3C plus this 7 here square. And that is the factors of this solution here. So those are the factors of that solution. So this is the same as 3C plus 7, 3C plus 7. Now, if you have another one here, 36 r square s plus 48 rs square plus 16 s cubed. Now, how will you factorize that? How will you factorize that? So before you factorize this, then you need to check whether there is a greatest common factor in all of them. So what can we factor out first, and then we simplify the one which is inside. So if you have 36, and then we have 48, and then we have 16. So what is dividing all this? What is the greatest common factor there? Is it 4? So if you divide by 4, so we have 4 outside. So we have S here, we also have S here, and then we also have S here. So the common one there is what? 1S, right? So we factor out the S there. So what will remain? So when you divide by 4 here, then what do you get? You get 9, and then R square plus, when you divide by 4, you get 12 RS plus what? When you divide by 4, you get 4S square. Are we together? So the common factor, when you open these, then what you get is 36 R square S plus 4 times 12 RS is 48 RS square. 4 times S, 4S square is what? 16 S cube. So you factor out the greatest common factor there. Then now you're able to factorize this using the perfect square. So of course, this is constant. So 4S there, you put it outside. Then you look at this now. Which kind of a perfect square is it giving us? It is an A plus what? A square, A plus B, and then it's square, right? Because all these are plus. So if you look at this, then for here, it will be what? 3R square plus, there is a 2, okay? And then AB is what? 3 and what? And 2, right? The 3 which is here, and then the square root of 4 here, which is 2, and then we have the RS there, and then plus the last one, which is what? 2S square there. So when you multiply 2 times 3 times 2, do we get 12? So we get 12 there, okay? So when you multiply 2 times 3 times, we still get 12. So finally, the factors will now be 4S outside. So we take this and this, 3R plus 2S squared. And that is our answer. So that's how we can factorize the perfect square. Okay, so we can do it the previous one again, show you how the one for the perfect square is going by. So if you have now 75 q square minus 180 q plus 108. So we said we factor out the common factor there, which was what? 3, right? So 3 outside, and then what you remain with is 25q square minus 60q plus what? Plus what was here? 36. It was there, is 36. So to factorize this, then 3 is still common there. So we come here. So here is 5q, then square. We carry this minus the way it is. So minus here. Okay, so minus there. So we have the 2 is common, it's constant there. 2 times 5 is, and then the square root of the 1, the constant over there is what? 6. And then q still remain like that, plus 6 square. So when you multiply 2 times 5 times 6, you still get 60. So our perfect square will be what? So it will now be 3 outside, this and this. So 5 cubed. So because of this minus here, then it will be minus 6 the square. So that is our factor. Is it clear? Are we together? Any question? Now let's come to section 6.3. Sums and difference of cubes. Sums and difference of cubes. So like what I said, if you are given a plus b, so we can start by a plus b raised to 1 is the same as a plus what? B, okay? So a plus b raised to 1 is the same as a plus b. A plus b squared is the same as a plus b, which is equals to what? A squared plus 2ab plus what? B squared. Now, when it comes to the cube, then a plus b cube is equals to a plus b times the what? A plus b squared. A plus b times a plus b squared, which is similar to a plus b times this a squared plus 2ab plus what? B squared. So it is similar to that. Now, for the cube, again, for a, so that, let's do it up to there. So if you have a minus b, so a minus b raised to 1 is the same as a minus b squared is the same as a squared minus 2ab plus what? B squared. A minus b cubed is the same as a minus b times a minus b squared, which is equals to a minus b times what? A squared minus 2ab plus b squared. So it is similar to that. So example. You done with this? Factorize x cubed minus 27. Factorize x cubed minus 27. Okay, so how will you factorize this? So like what we did in, if it is a cubed plus, so this is similar to x cubed minus 3 raised to what? 3 raised to 3, right? So that is similar to x cubed minus 3 raised to 3. Now, here, because this is a perfect cubic square, then that means this is like x cubed. Sorry. So this is like x minus 3 there. Okay? X minus 3 there. And then what? X x minus 3, and then also we have x plus 3, x plus 3. Okay. So because if you expand this, so if you expand this off, then this is similar to x minus 3, x plus 3 squared there. X minus 3, x plus 3 squared. Now, when we expand the x plus 3 there, so x minus 3 will come outside, then this is a perfect square, so x squared minus 2 times 3 with plus 2 times 3 x, and then plus 9. So x minus 3, x squared plus 6x plus 9. So will we get the answer there? Okay, so let's open the brackets. So if you open these brackets, then this x and this x will be what? X cubed, right? So this and this will be minus 6x. This one and this one is, no, sorry, this one is plus 6x. Then this one is plus 9x. When you open this, then it will be minus 3x squared. Then this and this is minus 18x, and then plus 27. Are we getting the correct answer? So 6 and 9 will give us what?
15.
Will give us
15, right?
15 minus 3. So that is not giving us the correct answer, right?
Wouldn't it be squared? The 6x?
Okay, let's do it again. So it is x cubed minus 27, which is the same as x cubed minus 3 cubed. X cubed minus 3 cubed. So here, then if we expand this, then definitely the first one will be x minus 3. Okay? X minus 3. Then there is another one which is a perfect square root to this, which will give us a 0. I mean, which will give us this cube there. So what will be the next one over here? So definitely there is the x squared. So that when we multiply this and this, then we get what? X cubed, okay? Then the next one is, it should be the last one here. The last one, which should be what? The last one here should be what? So that it gives us 27. 9. So that means there is a 9 there. So if there is a 9 there, and this one is a minus, so therefore, this should be what? A plus, okay? So there is a plus there. So what will be here so that we get a 0? So what will be there so that we get a 0?
Minus 3.
So here should be what? Plus 3. Okay, so that this is here 3x, so it will be now be, when you multiply this and this, you get x cubed, and then we have the 3 and 3 there, and the one which we get from here, so this is minus, and then this will be 9 when you multiply by 3, and it will go away with the 9x, which you get from multiplying this by x, okay? So this will now be our factor. So we cannot factorize this anymore because it is not giving us a what? A perfect square. Because a perfect square, there should be a 2, definitely. There should be a 2, and then the values of here, and then the value of here. So it should be 2, and then 1, and then what? 3. So here should have been 6. But now it's at 3, so it's not giving us a perfect square. So this is our final factorization. So we factorize up to this point. So we cannot factorize anymore. So when you multiply there, then what you get is x cubed minus 27. That's a tricky one. Eh? So you might get something like this in your exam. So another one is if you are given p minus 2 cubed minus 125. So p minus 2 cubed minus minus 125. So how will you factorize that? How will you factorize? So definitely this is similar to p minus 2 cube minus 5 or 5 cube. So minus 5 cube. So of course, like what we did in the other one, so the first one will be p minus 2 minus what? 5. Then we look for the next one. So to get the next one, so that means the next one there should be p minus 2 squared, okay? So that when you multiply this and this, you still get p minus 2 cubed. Are we together? Are we clear on that? So the next one here will be p minus 2 squared. So that when you open these brackets, p minus 2 and then p minus 2 squared, then you get p minus 2 cubed. Then the last one there should be what? 5 what? 5 square, right? So the last one there should be 5 square. So that when you multiply this last 5 and this one, what do you get? 5 raised to what? 3. So what will be our sign here? So our sign will be what? The plus. So what will be our value now in the next one? So what will be our value? So that we get a 0. So what will be our value here? So our value will be plus p minus 2 times the what? Times 5. So p minus 2 times 5. So when you multiply this, and then you come and multiply this one and this one, it will subtract and you get a 0. Okay? So are we able to factorize again from there? Are we able to factorize again from there? So here, if you open these brackets, then what you get is p minus 2 minus 5, of course, and then we have the p minus 2 square plus, when you open these brackets here, then it will be what? 5p minus what? Minus 10 plus what? 5 square. Okay? So when you open that brackets, it will be like that. So now here it will be p minus what? Minus 7, and then here it will be p minus 2 square plus 5p. So this is what? 25, right? Minus 10 plus 25. So p minus 7, and then p minus 2 square plus 5p. Okay, so minus 10 plus 25 is what? Plus 15, right? So plus 15. Then you can still open these brackets here. So when you open this bracket here, then you have p minus 7, which is outside. Then when you use the perfect square, then this is like p square minus 4p plus 4, and then plus this 5p here plus 15 there. So you open this one, which is the square, then you get this up to here, and then we have this, which is this one, and then we have that. So again, we can still factorize that p minus 7, and then, so there is a p, is there a p square? No, so p square. So this 4 minus 4p plus this, so it will be plus what? P. 4 and this 15 would be what? Plus what? Plus 19. So if you look at this again, you are not able to factorize this one anymore because of this. You cannot get the square root of what? Of 19. So it will just remain like that. Okay, so it seems like you want to go early. You still have like 8 minutes. So you can go look at the other ones, and then I will post the homework at around 6:30 or 7. And then it will be due at midnight. So make sure you send one file, okay? A PDF. Like when you scan, then you send as one file. So when you send as one file, it will be so easy to grade. So let's try this, and then the next coming exams, you will just be doing it online. So you'll just do it at home, and then you send it to me. The homeworks and the quizzes and everything we'll be doing at home. Okay? So our next exam, we will do it, I think it will be via Zoom. So at the time of exams, I will send you the link for the Zoom, and then you go online, and then you make sure you're there, I'm seeing you, and then you do your exam for like 1 hour. Then when you're done, you scan, and then you send it. So our next exam, we'll do it like that, right? Okay, so make sure you do your homework. The next homeworks are due, I think, by next week. So make sure you do your homework, and then get ready for the quiz. Okay, see you. Have a nice weekend.